Well, welcome everybody. We're going to give a presentation now on AGL and how I'd like to see the relationship with the SOAFEE project evolve over time and how we can complement each other as open source communities. So I'm just going to start off with a quick introduction to myself. I mean, those who know me know that I will bore you about rugby every day of the week. But I'm a technical director in Arm's Automotive business line. I'm the original architect of SOAFEE. I've been working on the SOAFEE project for within our open source group for a year and then within our business line for the last 3 years. I'm currently chair of the SOAFEE Technical Steering Committee. I'm an embedded software engineer by trade. I've had more than 20 years experience across different segments. I'm a huge open source enthusiast, right? If you cut me through the middle, I will say open source on my inside. And the last point here is that I love rugby, right? So I'm a coach, I'm a referee. This picture at the bottom here, that's my team winning the Eastern Counties Cup, beating our local rivals, Cambridge. The reason I love rugby, right, and I'll just a quick overview of that, is that we teach these young men, boys and young men, about teamwork, about working together, about collaboration, and how being a part of a team you can achieve much more than being an individual. And that's me to the core, right? So before I get into the contents of the presentation, right, we've got a meeting next week in Cologne in Germany, where we're bringing together the Eclipse SDV project, Covisa, AutoSAR, and SOAFEE as an initial step to work out how we have an outbound explanation of the relationship between these communities, because there's a lot of confusion with the many consortia in the automotive space at the moment about the roles and responsibilities of each. We're planning on having a joint statement as an output from that process that explains the relationship between the projects, the roles and responsibilities. But after that initial stage, we're planning on opening up the conversation to places like automotive-grade Linux as well, so we can evolve that understanding of who's solving which problems in what domain within the open source space around automotive and software-defined vehicle. Right, so introduction to SOAFEE first. So the first question is, why did Arm want to create SOAFEE? And for me, it's relatively straightforward. I've been doing this for years now. But the problem statement, and I call it the perfect storm of complexity. So I think that slide's just auto-progressing, so I may have to. The first angle is software complexity. Right? As we move towards software-defined vehicles, the software is becoming more and more complex. We're expressing more of the features and capabilities of our end product in software. Sorry, there's a squeaky floor here. And the software that we've traditionally been defining is very intricately tied to a BSP. So we kind of get locked into a delivery from our silicon provider with the interfaces that they expose to us through to the applications that we write at the end. That is in no way a definition of software defined because it's defined by the features in the hardware. So in my mind, that's a definition of hardware defined, and the software is just enabling the features that are available in the silicon that we have. The problem with that model, though, is that the software that we've written is tied to a BSP and an SoC, a system on chip. That software is not portable. It's not easy to take that software and move it from platform A to platform B. So we have a problem of NRE, of re-engineering the hard work that we've already done in the first production over to the second. But in the automotive space, this is getting even harder because we're going through a centralization of compute within the automotive domain as well, where a lot more of the complexity of the vehicle architecture is being shrunk down into an SoC, where we're bringing in heterogeneous compute capabilities. We've got multiple compute domains within that SoC. So as a software architect, I now not only have to worry about the features delivered to me in the BSP that comes from the silicon partner, but also have to be cognizant of the underlying system architecture, what compute islands I have available to me, the real-time processors, the microcontrollers, all of these low-level features, how they interconnect with each other, what the communications channels are, the bandwidths available to me, the real-time characteristics. So I've now created software that is not only tied to a BSP, but also to a physical implementation of an SOC architecture. So that's complexity squared. Right? My software is now most definitely hardware-defined, even though we call it a software-defined vehicle, because there's no way that I can take that software to my next start of production system architecture and have it work on day one. I'm missing a slide in here now. Okay, so I'm going to talk through what I've done here. So when I looked at this problem, the question is, where have I seen levels of software complexity like this before, and how has the ecosystem solved it? And when we think about that, we think about the cloud service providers, how they've managed to commoditize access to the complex infrastructure that they have, the compute, the NPU, the GPU, all of the complexity they have. How do they commoditize that to a software ecosystem so they can easily make use of it and actually scale and make their platforms more available to users? When you think about that, the way they've done it is through standardization and things like the cloud-native processes, DevOps workflows, the best practices around CI/CD, and standardization in how we deploy and manage the deployment of those workloads. So the question we then asked was, well, why can't I just take cloud native as it stands today and deploy it into a vehicle? Take an orchestrator, take Kubernetes, take K3S, whichever one you want, and put it into vehicle. And the answer is obvious, right? Those technologies today have no visibility or capabilities in functional safety and real-time and other aspects, right? So they weren't designed for safe real-time environments that we have within vehicle. So SOAFEE was created with a very simple goal, is to take the cloud-native processes that we have today, DevOps, continuous delivery, microservices, containers, all of that good stuff, and add all of the additional features, functional safety, real-time, heterogeneous compute, accelerator awareness, IO locality. All of these things become really important when thinking about the real-time constraints that we have in our deployed systems. So, SOAFEE's three things, primarily. Firstly, it's an industry initiative. We wanted to make sure we brought the industry together to have a conversation around how we manage the complexity of that software-defined vehicle future. We created the special interest group with that vision, and we have, at the moment, I think we have 100 members who are in the process of signing up. We have 80 or 90 publicly announced members now, and that number is growing. And we're making sure that we bring industry veterans into the group. We have representation from cloud service providers, OS vendors, tools providers, the whole ecosystem around that DevOps workflow. The second thing is it's a software architecture. So I don't think of SOAFEE as an open source project. I think of it as an open standards project. We happen to have a reference implementation that implements to the standards, but the whole goal of SOAFEE is to work upstream with OASIS, with OCI, with CNCF, and other standards bodies to augment their standards to make them applicable in a real-time and safety-aware environment. The reason that's important is it means that downstream consumers of those standards can implement to those standards. So if you look at the current SOAFEE membership, we have companies like Red Hat. I want to say a traditional open source company, but in recent news, right? So that's, oh goodness me. I'm not sure, how we view Red Hat at the moment as a community. But we have Red Hat who are working in that space. But we also have more traditional automotive vendors like QNX. And the goal is that the go-to-market solution for SOAFEE partners is not to take EWOL, which is our reference implementation, but rather to go to a commercial software vendor who is implementing to those standards. So you get a commercially supported, functionally safe solution that is your go-to-market partner. And the point of this presentation is going to be, there's no reason why AGL can't be that go-to-market partner. So what we're going to try and do is come up with a story where we enable AGL to have more applicability in commercially deployed solutions. So, a quick view on the current SOAFEE Focus. The way SOAFEE works is through the definition of blueprints. And a blueprint defines a vertical integration of software, for which AGL could end up being one. And that vertical integration is, at the top end, we have a definition of the workloads, the things that we want to deploy. And this is the important thing to the OEMs, right? This is actually their go-to-market business. In this example, we're showing OpenAD Kit, which is the AutoWare Foundation's microservices-based implementation of their AutoWare autonomous drive solution. In the middle here, we have the SOAFEE Architecture, which is basically that expression of standards, again, in its reference implementation form. So here we're showing EWOL. From an ARM perspective, we're sitting on system-ready compliant firmware, which gives us a consistent mechanism for boot, for secure boot, for firmware updates, PSA services for security and the like. So we're standardizing at all the layers of the stack with a ARM-based hardware platform at the bottom. This definition of a blueprint enables the SOAFEE ecosystem to look critically at that and say, what are the requirements for those containerized applications at the top end, and what is missing from the current OCI specifications to enable them to meet their needs. Now, an interesting subtlety about this picture is that when the microservices-based architecture was created with the AutoWare Foundation, if we look at each of these containers now, each one has very unique runtime requirements. So if we take planning as an example, trajectory planning tends to be a high single-threaded performant workload. So we need to have a big CPU to do the computation for that particular problem. If we look at perception as a separate container, we tend to have high vectorization requirements, GPU requirements, NPU requirements in that space, but not necessarily as high as CPU performance. Vehicle interface is another interesting one. This one will tend to have a high safety requirement because this is the module that is responsible for controlling the steering, the accelerators, and the brakes. So in the automotive space, we'll have ASIL D requirements applied on that, whereas we don't necessarily on the others. When I think about the relationship with this blueprint and the in-vehicle orchestrator that's going to be deploying these workloads, I can now take a look at that complex SOC architecture where I have multiple compute domains, each with different characteristics, and make an intelligent decision on where each of those containers should be deployed in order to meet the functional and non-functional requirements of that particular workload. So for instance, vehicle interface will want to go on a real-time processor with split lock capabilities so we can do systematic ASIL D certification. Planning will want to go on the high-end Neoverse cores that we have available so that we can get that high compute capability. So that's a blueprint, right? And we have the blueprints deployed to an integration lab. We're running continual integration on these. We only have the OpenAD Kit blueprints at the moment. We have many more coming through the pipeline, including IVI blueprints, where I'd like to see AGL as a blueprint. We're working with, am I allowed to say Android Automotive as well in this forum? I think I can. It was mentioned yesterday in the keynotes. So many blueprints in flight. Now, the way we define the architecture for SOAFEE is through evolution of these blueprints. We work closely with a partner, Kern Concept, to deliver features and capabilities that we showcased at Embedded World earlier this year that showcase the migration of the vehicle interface container onto a real-time processor. And I'll show an overview of that architecture here. So, if we look on the right-hand side, that was the original blueprint that we showed earlier. We've added a few extra things to this. So on the left of that visualization here, we have the EWAL, which is the reference implementation, running the maps, perception, and planning containers, identical to the previous instantiation of the blueprint. We've added a visualization container as well, because this was designed for demonstration, so the thing was portable. So we actually run a workload in there that attaches to the screen and shows the visualization of the simulation that's ongoing. The interesting thing, though, is on the left-hand side, we have the AutoWare vehicle interface running it as a microkernel-based containerized solution. And this is running on an RTOS, running on a Cortex R52, running in locked mode. So we've got two cores running locked together with this application running on top. So assuming that code has been written correctly and the underlying IP that gives us systematic fault, I think I got my terminology wrong there. I'm not a safety expert, right? So I'll just put that out there. Right, but we are able to get ASIL D certification now for the workload that is running in there. So what SOAFEE now does is it analyzes this environment and says, okay, what do we need to do in order to augment the features of the orchestrator to enable it to deploy that containerized workload onto a Cortex R? What do we need to do to the OCI specification to add the features that are a microkernel-based container environment? What has to happen at the runtime specification and the image specification to make that a reality? What do we need to do in the tooling space, even, to say, I want to test and validate a Cortex R-based application in my CI environment in the cloud? So what's the virtual execution environment look like? There's a load of questions to be asked, and that's the function of that SOAFEE community, is to solve the tooling, the standards problems to enable these features to be deployed. The output of this is ongoing at the moment. So when we look at I saw some people screwing their face up when I talked about containers on Cortex R, right? And I agree with you. Current OCI specification doesn't enable it. But what we're doing, because actually when you look at the runtime specification, there's nothing in it that mandates the use of Linux. Okay? We can run on any execution environment. And when you think about the role of the container runtime environment, it is to give us a safe execution environment for a thing. On Linux, we use C groups and other technologies to give us that execution environment, but there's no reason why it can't be a microkernel-based solution. And that's what we're trying to do here. So our partners EPAM have been working very closely with us. They have pushed a pull request to the OCI runtime specification, that link there, that enables them to deploy a Zen-based X-run container runtime environment that is purely designed for microkernel execution. There's no Linux involved in there at all. That's very EPAM specific, very Zen specific, right? So that isn't a standard. So what SOAFEE is doing then is looking at what EPAM have done there and making sure that it is a portable solution so that we can take an L4E environment or a QNX environment or other environments and still have the ability to express that as an execution environment that is understood by OCI. And once it's understood by OCI, we can add the integration with the orchestrator in vehicle as well. And that's how we get to the point of having a managed deployable solution that has real-time and application core processing capabilities within it. Because this is a microkernel-based solution, there's no reason why we can't extend this to microcontrollers as well. So the vision of SOAFEE is that we can have a holistic view of all software running across the whole of the vehicle so that we can manage the complex interactions between those software components, make sure the APIs that they're talking are compatible with each other at all points. Right, So, like the keynote speakers yesterday, I haven't been presenting publicly in conferences for a long time now, and I haven't timed this presentation, so I'm hoping I'm going to be on time with this. But I want to go quickly through now how I see this working with AGL, because I do think it's a perfect partnership that we could create here. So when I look at a SOAFEE deployed solution, because it's software-defined vehicle, we're not just talking about IVI. And as was said yesterday, AGL have views on doing many more features within the vehicle. So the software-defined expert group that you have set up, I think aligns very nicely with the conversations that we're having in the standards space within SOAFEE. So I'd like to forge good ties between those two groups. But if you look at what we're trying to deploy here, we want to have some kind of in-vehicle infotainment, a digital cockpit solution that's deployed across the fabric of my vehicle, but also with ADAS and autonomous drive capability that is also deployed somewhere within the fabric of my vehicle. Some mechanism for OTA so that I can update the solution as and when I need, add additional features, which is the actual business reason why the OEMs want to go to software-defined vehicles, so they can keep upselling additional features into that vehicle to monetize the vehicle for the whole life cycle of it, rather than just on the day that it rolls off the forecourt. So that's a very simple overview of a vehicle, right? We've got the things that are going to entertain us in there whilst the car is driving itself, and I can add new features to it. Right, job done. So that portability layer in the middle, I think, is identical to the output that will come from your SDV expert group. We ought to be coming to the same conclusions in this space, because we need to make sure that we have cohesion of the standards across all of the consortium, because we don't want to make any kind of fragmentation here. So the question then becomes, what is the relationship between AGL and SOAFEE in this kind of a model? Right. So the first step is that SOAFEE enables that eWAL bit, the implementation at the bottom end, to be anything, because we don't mandate that you use our Yocto-based eWAL. Right? That is just there to educate people on how a containerized environment works. It's a tool for giving the ecosystem the things they need to explore how software-defined in a cloud-native way works. So there's no reason why that bottom layer there can't be AGL, right? So if AGL is that bottom slice, it means that you can be the full-stack solution. And the benefit of that is that you can then take the containers that the AutoAware Foundation are producing for autonomous drive and ADAS and just deploy them alongside using your full-stack solution. You can take eSync's OTA solution, which is looking specifically at secure OTA for the automotive requirements, and deploy that. The point I'm getting to is that this gives AGL-based solutions more options for OEMs to adopt, because you're not mandating it's this way or not this way. Right? You're giving options to take whichever part. One subtlety here. So when I look at this AGL implementation here, in my mind it would be awesome if we could express the cockpit zone. So the graphics part, the bit that the people interact with. If you containerize that and deploy using the SOAFEE sanctioned standards, then that also gives you more options for deploying AGL in OEM solutions. Because if they choose QNX as their implementation of the base standards, you still have a route to deploying AGL, the pretty part of AGL, into that end solution. So, benefits to AGL, I think I've covered those already. I think giving the OEMs more choice is of huge value, right? It's not, you're giving them the choice through the standards, and all of the OEMs that we've spoken to are desperate for more standardization within the automotive space. And it gives you flexibility as well. Like I say, you can start to make use of the the other areas that SOAFEE are looking in, the tooling, the shift-left capabilities, the ability to deploy virtual platforms so you can test before silicon is available. We need to be writing code for hardware that will be available in 2 years' time. And the way we do that is through virtual prototyping, and we're building the solutions with SOAFEE partners like Synopsys to enable us to do that level of deep simulation in that shift-left model. Next steps as I would like to see them. This is all my opinion, and I'd love to bring you guys along. I would love to see a deeper collaboration between SOAFEE and AGL. I'd love to see your logo on our website and our logo on your website to show to the community that we have a deep understanding of what we are trying to do together. I would love to see an AGL blueprint so that the SOAFEE community can become aware of the unique requirements that AGL have to deploy OCI compliant containerized solutions, because that's where we do the gap analysis. That's where we find where the problems are. I'd love to have a working demonstrator of AGL on the SOAFEE reference platform, but also the other SOAFEE partners. So people like, we have Red Hat who are building their IVOS, QNX, SUSE, Wind River, and others are all building that base platform that is SOAFEE compliant. And then we can show AGL on many of the hardware platforms from the SOAFEE silicon partners who are building up the standard interfaces to those components. So, in conclusion, I think SOAFEE and AGL can complement each other wonderfully. We're not saying that AGL needs to conform to SOAFEE, but AGL can help SOAFEE to direct upstream standards to make them compatible with the requirements for AGL. We come together as a community is a much more productive way of migrating standards than going as individuals. I think we add flexibility to the AGL solutions, and I believe it creates more business opportunities as well. So, SOAFEE loves automotive grade Linux. Thank you very much. Do we have any questions?
What? Me first? So I'm just wondering, you're having a big meeting next week and you didn't even invite AGL. Why not?
We wanted to constrain the, we could invite everyone to stage one, right, of that kind of a collaboration. And it's the too many cooks spoil the broth thing. It wasn't me that organized it, so don't shoot the messenger, right? But the questions that we were getting as a SOAFEE community is, what's the relationship with AutoSAR? Should I join SOAFEE or should I join the Eclipse SDV project? So it was primarily around the direct questions we were getting as the SOAFEE and ARM go-to-market teams. So it's not going to be on day one, right? But we are absolutely wanting to have that collaboration across all of the initiatives. So please don't take it as a snub, because it is not meant as a snub at all.
So I'm trying to understand. You know, I've read through the SOAFEE Architecture document, and like you said, you're not an open source project, you're a standards body. So you know, obviously, the SOAFEE members know about our SDV expert group. We've recently, started an RTOS effort to work on how so there's a lot of overlap, I think.
Yep.
So why isn't ARM participating in these groups at this point?
We have very limited engineering resources, and the way ARM engineering tends to work is that we focus on architecture enablement, not on larger ecosystem enablement. So our open source software team will work on v9.x features in the Zen hypervisor, rather than features within a particular larger ecosystem. It's the way our engineering teams have tended to work. ARM works very closely with the ecosystem to give the tools and the enablement that is needed. So I don't have engineers. I don't have a huge number of engineers that are working on SOAFEE. And actually, if you look at the EWAL reference implementation that our software team created initially, we've now handed that to Linaro for maintenance because our engineering team are working on Cortex-R82 enablement for Zen and Linux running on RTOS. That's the kind of work that we normally do within the ARM engineering teams.
Yeah, I was going to ask about what the relationship is between ARM and Linaro on SOAFEE, and I guess you just kind of alluded to that.
So we are funding Linaro to put engineers on maintaining aspects of the SOAFEE architecture. So EWOL, the integration lab is run by Linaro, but it's been designed using Lava so that we can do remote labs. So that the Red Hat lab is set up as a remote behind Red Hat's firewalls so that they can do whatever they want to with their own thing. We're working with companies like Renesas and NXP for them to set up their remote labs as well. So our relationship with Linaro is that we're obviously funding members of Linaro, so we pay for engineers to work on things that aren't necessarily within our direct IP enablement space. It's a complex relationship, but ARM as an IP company, our primary business is in enabling that IP within ecosystems. So languages, libraries, tools like compilers, making sure the LLVM, Rust, all that stuff, right? That's where we tend to do the majority of our engineering effort from a software and open source perspective.
Yeah, so I guess my last question, then I'll let Jerry ask his questions because I know he's going to have some. So how are you expecting SOAFEE to work its way into AGL if, we're an open source project. We rely on people to come to us with code.
Yep.
And the way that the Covisa, VSS stuff came to us was there was actually some code we could use. So we've now worked with that community. So I guess I'm trying to figure out how you think that relationship would actually work. Are you thinking that we're going to fund engineers to work on this stuff?
No. If you look at the work we did with Kern Concepts to build out a microkernel-based container execution environment, that is coming with code, right? But the point of that code, that is not production deployable code because you need to send an army of engineers with it to carefully put the thing together before it will boot up and run. Right? And there's no real value in making that specific proof of concept turnkey. What we want to do next is look at that proof of concept and work on the standards that make it a reality. So that's where we bring organizations within the SOAFEE community that have a go-to-market and a code-first mentality to do that implementation work because we're now working towards a standard. And because there's a standard in place, there's value to the ecosystem, there's value to the OEMs, it creates a route to market for the SOAFEE partners. So it's a complex relationship, I'll agree, right? But SOAFEE is not a code-first organization by itself, but the way that we're evolving the blueprint process will be so that there is demonstrable things that we then want to turn into deployable things. Jerry, I think you're next.
If there are any other questions, I will just give a comment maybe in the end. Okay, thank you so much, Matt, for your presentation. It's very impressive. And I think you mentioned the SDVEG for several times, and even in the keynote, I think all of the keynotes are talking about the cooperation within the whole industry with different organizations. So as the leader of SDVEG, I think the connection between the SDVEG and SOAFEE is necessary. Although I think maybe, for example, if AGL can join the SOAFEE, is something that need to be decided in steering committee or advisory board. But for the technical point of view, I think we can already start some kind of conversation. For example, maybe I thought it should be the last question, last comment. So, are there any other questions?
Oh, okay. Okay, we all done? Hey, thank you very much.
Thank you.